Welcome everyone. Thank you for joining us today for our webinar on Lagoon Sludge Cleanouts. I'm Kevin Bossy, the CEO of Bishop Water Technologies. My company specializes in developing, manufacturing and installing simple, low-energy solutions for solids management and nutrient removal. Over the past 10 years, we've delivered over 100 projects with our solids management solution to collect, dewater, consolidate slurry materials from wastewater lagoons, stormwater ponds, and various other commercial and industrial applications. During that time, we've become an industry leader in sludge removal and passive dewatering. And I'm looking forward to sharing what we've learned with you in this webinar today. Now, I'd like to introduce my co-presenter, Tyler Anderson.
All right, thank you, Kevin. I'm Tyler Anderson, a project team leader with Bishop Water Technologies. I'm involved in virtually every aspect of our lagoon sludge removal projects and oversee steps such as proposals, site assessments, dewaterability testing, project organization, and project delivery. In my prior roles, I've also gained significant experience in water quality management and apply those skills to dewatering projects to ensure regulatory compliance and to minimize environmental impact.
Thank you, Tyler. How do we know that excess sludge is causing operational performance issues with the lagoon? In some cases, this can be very obvious. For example, you may see sludge floating at the surface of your lagoon, or even sludge islands that rise above the water level and create a nice spot for birds to sit. But these sludge islands and significant accumulations in the sludge blanket can also release methane, hydrogen sulfide gas, which we know is very unpleasant and can lead to odor complaints from residents. When operators sample the lagoon, they will undoubtedly measure high turbidity and probably notice a change in color too. Sludge particles can also carry over into the effluent, resulting in reduced clarity and abnormally high or even non-compliant TSS measurements. As sludge accumulates, it also reduces storage capacity and retention time, which can adversely impact nutrient removal. This can lead not only to algae blooms, but also high levels of nutrients and the risk of exceedances. Another issue is the formation of channels that cause short-circuiting of wastewater flow. When this happens, wastewater travels relatively quickly through the lagoon from the inlet to the outlet rather than dispersing and remaining for the optimal residence time. Sludge accumulation can also cause washout, where large influent volumes, like during a storm event, can overwhelm the lagoon and cause a large amount of the microbial population to get carried away. It can take days or weeks to recover from this event, during which lagoon performance will be compromised. Ventful feedback is a condition that occurs in the spring in non-aerated lagoons. As the water warms, it creates turbulence that stirs up the sludge blanket and releases accumulated hydrogen sulfide and nutrients. In the worst cases, the concentrations of some wastewater constituents can be higher in the effluent than in the influent. And the last item on our list is related to operator access and maintenance. We've seen instances where excessive sludge can block access to components that need regular maintenance, such as aeration, inlet structures, force mains, and others. This flowchart shows how many of the conditions that we just looked at can individually or simultaneously contribute to decreased lagoon performance and poor effluent quality. You can see that sludge accumulation is a referral point for many of the operational issues that arise. Once excessive sludge is identified as the cause of a lagoon's operational issues, we can begin planning the desludging project. But before we go deeper into that process, I would like to start with a bit of a warning. Some of the mishaps that can occur. One of the most important steps is knowing what the desludging project is supposed to achieve, because that helps determine how much sludge should be removed and from what areas of the lagoon. But without a clearly defined objective, it's difficult to scope the project and achieve measurable success. Underestimating the sludge volume is also at the top of our list for things that we don't want to have happen. If this occurs and there's a lot more sludge in the lagoon than was estimated, it can add significant time, cost, and community disruption to a project. Inadequate sludge sampling is also a situation that you don't want to find yourself in. The more samples we take, the better we understand the sludge characteristics throughout the sludge blanket. We also use these samples to do dewaterability testing and determine the best polymer for the lagoon. If the polymer or dose rate is suboptimal, then we can see slow dewatering and we may not get the best dewatering performance. That means more trucks will be needed to carry away wetter sludge, which increases costs. Effluent quality can also be adversely affected. Too much polymer can leave a residual in the effluent, and too little may not sufficiently retain fine particles, leading to high TSS filtrate. Great care should also be taken to understand the contaminants that are in the sludge, such as metals. These contaminants greatly influence the disposal or repurposing options for the sludge. It's best to know about these before the sludge comes out of the lagoon, so you can explore disposal options and ensure you have a plan and budget to carry out the disposal. Algae. You wouldn't think it can be a big problem, but it is, and can seriously impact dewatering. Since the amount of algae changes seasonally, we need to be aware of it and ensure the desludging team is ready to handle the situation. The last two are specific to geotextile dewatering containers. There is a great deal of planning and control needed to avoid overfilling the containers and risk bursting. If they are to be stacked at a site, then the team also has to be very careful to avoid having the bags roll off or slip down in between the gaps of the layer below it. The images at the left show what happened when a team of DIYers in the US tried to perform a sludge removal project. To be clear, this isn't a geotube, and we were not the contractor at the site. In the top photo, you can see that the bag was filled to an enormous height, and it didn't take long for it to burst. The lower photo shows the extent of the sludge tsunami that resulted. Now we know what to watch out for, let's talk about how to do it right. Desludging begins with a comprehensive assessment of the lagoon or lagoons. Sludge usually accumulates unevenly in a lagoon, with heavier materials like grit settling near the inlet and lighter materials being dispersed farther and accumulating based on flow patterns, wind, and aeration. The image on the top left is a sludge map of a lagoon showing high accumulations in the red area and moderate accumulations in the yellow. We take samples at predetermined points to estimate the sludge volume and the available treatment volume. The number of samples are based on the size of the lagoon and the sludge features. And of course, more sampling is better to understand the sludge profile and make good calculations. There are several ways to measure sludge volume, ranging from very simple to very sophisticated. One of the easiest and most common ways to do it is with a sludge judge, shown top left. That's just a PVC pipe with a flat valve that the operator lowers down into the sludge layer from a boat. This is a good system because it takes depth measurement and a core sample at the same time. But once the solids concentration is above 5%, it becomes more difficult to push the tube down into the sludge. A sludge gun is also a great system that can be used in combination with the sludge judge, shown bottom left. This electronic device uses infrared light to detect the sludge bed. The sensor is calibrated to ignore suspended solids and sounds a tone when it reaches a sludge of a certain density. The user reads marks on a string to determine the sludge depth. And a third method that is commonly used is a bathymetric survey. This sonar mapping system is usually mounted on a small GPS-controlled boat that maps the entire lagoon in a grid pattern. It's the most accurate way to create a sludge map. The bottom right image shows the details we get from this technology. It's also really important to have a good as-built drawings of the lagoon. With those drawings, we can overlay the survey data with the lagoon profile to very accurately calculate the sludge depth and volume. This worksheet is an example of how data from the sludge judge or sludge gun would be recorded. This part isn't complicated, but it's only as good as the amount of data that is collected for it. The more data points we have, the better our sludge map and sludge estimate. As we mentioned earlier, sludge samples are critical. They're often collected as the survey is being done. Repetitive, but this is so important because sludge density or percent solids can vary considerably throughout the lagoon. Lagoons that have well-aged mature sludge and maybe haven't been cleaned for 20 years might have very dense sludge. The amount of grit and volatile organics can also influence density. We've seen swings that range from 3 to 5% in one area of a lagoon to more than 40% in other areas. If you miss that dense area in your survey and don't account for it in the estimate of sludge volume, you will be surprised to see a lot more sludge coming out of the lagoon than you planned for. When we do our testing, we ask for a 20-litre pail of sludge with samples that have been collected from multiple points in the lagoon. Large lagoons may require more than one pail. We combine the samples to create an average sludge mix and do our testing on that. With that sample and the sludge survey, we can now determine everything shown in the list: sludge density, total estimated sludge volume, optimal polymer, sludge dewaterability, filtrate quality, estimated dewatered sludge volume, contaminants of concern, and disposal costs. Once we've determined how much sludge is in the lagoon, we can think about how much to take out. There are a number of factors that can be considered at this point. First, what is the purpose of the desludging project? It can be one or all of the benefits shown on this slide: restore treatment capacity, improve effluent quality, reduce emissions, of odorous gases, mitigate short-circuiting, or improve access to lagoon infrastructure. But as you'd expect, all of these must be weighed against the available budget. And that budget is not only for removing and dewatering the sludge, but also the cost of hauling and disposal or relocation of the sludge. Many lagoon sites opt to do everything in one shot. Maybe it's been 15 or 20 years since the last desludging, and they just want to get it done and not worry about it until another 20 years goes by. But there's another option, which is a partial lagoon desludging. This can achieve some or all of the objectives shown on the last slide, and also provide some budgeting and operational flexibility. One of the biggest benefits is that it can defer the cost of a full lagoon cleanout over several years instead of a larger one-time expense. We have performed several partial cleanouts with our Bishop Solids Management solution that is based on passive geotube dewatering. What we typically do is size the bags to provide 2 or 3 years of capacity so they can remain on site, continue dewatering, and enable the client to avoid hauling and disposal costs. We return to these sites on an annual basis to continue the cleanout and add materials to the geotubes. Another advantage is that the annual sludge management plan is continually restoring treatment capacity and reducing the risk of poor performance caused by sludge accumulation. Here's an example of a partial lagoon cleanout project. In 2011, we removed about 250 bone-dry metric tons of sludge from lagoons near Cornwall, Ontario. These went into 4 large geotube containers that remained on the site. In 2013, we returned and continued pumping into those bags. Each time they were left at the site to continue dewatering. They also froze over the winter, which significantly enhances the dewatering process. The original geotubes are no longer at site, but we still go back to remove sludge as part of a maintenance strategy. Going back to our planning process, the next step, sludge will be removed from the lagoon. There are 2 options, each have distinctive cases and benefits. First is a hydraulic dredge that uses an auger to gather sludge and pump it out of the lagoon. One big advantage of this is that the lagoon can often remain in operation while the dredging and desludging is done. The aeration equipment and other submerged equipment can remain in place, and there is little risk of damage to the liner. There are many types and sizes of dredges, even automated ones that use GPS controls to desludge the lagoon. The second option is pushing the sludge with tracked equipment to a pump that is set up in the lagoon. This can be a more cost-effective approach for a total cleanout and offers greater efficiency since the sludge is visible and can be easily scraped up. One downside, however, is the lagoon must be decommissioned and drained, and if it's an aerated lagoon, then the aeration equipment must also be removed. I should also mention that there is a risk of damage to lagoon liners with this method. Some jurisdictions, such as Prince Edward Island, don't allow tracked equipment to enter a lagoon to ensure that no damage to the liner will occur. It's important to know if there are restrictions in your area when planning the project. There are a few options to consider for the dewatering the sludge too. Sometimes sites choose not to dewater sludge, and we have seen projects where liquid sludge is immediately hauled away for land application. This method does rely heavily on trucking, and it can become costly. Even more so if the land where the sludge is being applied isn't close by. Let's quickly have a look at some other dewatering options. Mechanical options include centrifuges and belt presses. These can provide automated operation and can reduce sludge weight by 90% or more. There are many mobile options that are quite compact, which makes them ideal for sites with space constraints. However, they are quite energy intensive to operate and have a limited rate at which they can accept sludge, usually only a few hundred liters per minute. Dewatered solids are often collected in bins and are hauled away regularly. Another option is passive dewatering, such as our Bishop Solids Management solution, which we introduced when we talked about partial cleanouts. This is a gravity-based process that uses far less energy than mechanical systems. Since the solids are collected and contained in the geotube, it enables the solids to remain on site for an extended period. It does require more space than mechanical options, but the geotube are customizable to fit the available space and can be stacked to further reduce the size of the dewatering cell. One other important advantage is that this process can accept solids as fast as they can be pumped, whether it's 2,000 or 10,000 liters per minute. At this point, I'll turn the presentation over to Tyler.
Thanks, Kevin. Before we continue, I want to say a bit more about the Bishop Solids Management solution and its application for lagoon desludging. We've used this process for more than a decade at sites throughout Canada. It's a complete customizable solution that includes sludge removal, sludge conditioning, dewatering, and containment. As Kevin said in the previous slide, it's very energy efficient with automated polymer dosing and flow controls that make it very easy to use. Unlike centrifuges and belt presses, our process incorporates very few moving parts, which makes it inherently reliable. We can achieve high level of dry solids using only geotube filtration, specially selected dewatering polymers, and gravity. Although we're talking about lagoon sludge today, this system is very effective for virtually any organic or inorganic slurry material, so it can be used for storm ponds, freshwater sediments, or mine tailings, to name a few other common applications. In addition to dewatering, optimized chemical conditioning also enables it to retain and reduce contaminants such as BOD, TSS, phosphorus, nitrogen, and metals, improving the quality of the filtrate. Very quickly, here's how it works. Slurried solids are removed from the lagoon and pumped into the geotube. As they are pumped, our VPAS, non-mechanical polymer system, mixes and activates polymer in a single step, then injects it directly into the sludge feed line. Polymer accelerates dewatering and also helps retain fine particles and contaminants within the geotube. Dewatering begins as soon as the solids enter the geotube, and we can immediately see a large volume of water permeating through the pores of the container. Once the bag is full or the desired amount of sludge has been processed, we disconnect the hoses and dewatering continues. The longer the solids remain in the container, the more water is removed. The freeze-thaw cycle also enhances dewatering as frost creates void spaces in the material, allowing for better water movement. The bag can be cut open at any time after dewatering, and the solids can be removed for disposal or can be land applied if suitable. After several weeks or months of consolidation, the dewatered solids are more like soil than the sludge that was originally pumped in. We have received several industry awards for our work with this system. Our first was for a permanent system at the Greenway Wastewater Treatment Facility in London. The Bishop Solids Management Solution is used to collect incinerated sludge fly ash that was previously stored in an on-site lagoon. This process of containing and dewatering the solids completely eliminates the need for the lagoon and greatly reduces the hauling and disposal costs associated with removing the solids from the site. The next project is at the Eganville Wastewater Treatment Plant, where our solids management solution is used to collect and dewater septage from local haulers. The biosolids are pumped directly into geotube containers, and the high-strength filtrate is directed to the adjacent wastewater treatment plant for treatment. Once dewatered and stabilized, the biosolids are used for land application. Another award-winning project is in Perth, Ontario, where the system collects and dewaters process residuals from the town's water treatment plant. The filtrate from the geotube is of such high quality that it is discharged directly to the Tay River without any further treatment. The system also saved over $6 million in capital costs for the town, which was considering building a mechanical plant to deal with the solids. Here are a few more examples of some challenging applications that we've been involved with using our Bishop Solids Management Solution and geotube containers. Permanent systems to handle waste sludge from municipal wastewater treatment plants. Collection and dewatering of contaminated sediment and soils at industrial sites. Dredging and dewatering of solids from stormwater ponds. Collection and dewatering of excess soils at construction sites. On-site systems to collect, process waste, and treat wash water at agricultural sites. And shoreline systems to protect valuable coastal areas from erosion. Turning back to our lagoon desludging discussion, let's look at how we use the data from the earlier steps to make some calculations. Our team uses customized electronic geotube planning tools that use input data such as the sludge volume, solids content, pumping rates, and the anticipated dewatering performance to accurately calculate the dewatered sludge volume and the sludge weight, the size and quantity of the geotube containers, the required footprint of the laydown area, and the duration of the cleanout project. These tools are continually updated by Tenkata, the geotube manufacturer, to refine the process and improve their accuracy. Regardless of which dewatering method you choose for your project, be sure that the vendor can provide highly accurate estimates that are based on the data that you've collected in the earlier stages and leverages their operational experience with their process. Don't accept ballpark estimates or ranges of potential outcomes because errors can set off a cascade of problems that can add considerable time and cost to the project. Here are a few other important considerations as you're prepared for the desludging project. Experience plays a critical role in identifying these planning considerations and determining the best methods for the site setup. Is there sufficient space for equipment and a dewatering pad within the appropriate proximity to the lagoons? How will the piping, hoses, and valves be laid out at the site? Where will chemical injection and sampling points be located? Where will the filtrate go? This is especially important if your lagoon will be shut down. If there's a second lagoon, it could go there. But what if there isn't a second lagoon cell? A temporary secondary treatment containment process may be needed. It's also possible that filtrate might be good enough to be discharged to a receiving body, but in either case, effluent monitoring will be required to ensure discharge compliance. Keep in mind that even if your filtrate is going back into a lagoon, it may be necessary to track volumes and monitor the filtrate quality. Schedule your cleanout when nothing else is happening that could be disruptive. This includes other maintenance or construction activities at the plant or lagoon site and events that could cause large inflows into the plant. Things like local industries that increase discharge at certain times of year, community events, or seasonal periods with higher precipitation. Finally, we need to think about what will happen to the sludge that's been removed. Depending on how the sludge is stored at the site, local regulations may dictate how long solids can remain at the site once removed from the lagoon. There are a number of options for the sludge that include land application, landscape material, landfill disposal, or others. The fate depends on the classification of your sludge into categories set out regionally through applicable regulations, such as Class A, Class B, hazardous material. These classifications are determined by results of analytical testing, and the criteria to compare against can vary by region. We regularly encounter T-clip metals test, pathogen analysis, and slump testing. As we saw at the beginning of this presentation, sludge collection and dewatering isn't a DIY job, so some specialized and experienced help is required. There are at least a couple of ways to think about how to structure your project for procurement. One way is to break it up into two parts. The first part can focus on information gathering, and a company can be hired to do all the sludge measurement, sludge testing, and calculations. Once that information is in hand, it can be used to develop a comprehensive scope of work for the desludging project, and an RFP can be passed on to the service providers for a competitive or sole source procurement. The other option is to hire a single company to do everything, perhaps under a consulting arrangement where they handle all aspects of the project. The project lead might use their own resources or hire subcontractors to handle various aspects of the project. But whatever they choose to do, the client is willing to deal with a single point of accountability. To develop the specification for a lagoon cleanout project, reference all of the steps and objectives that we've talked about in this webinar. The specification should include a clear breakdown of each of those at each stage of the project. Some of the most important points to include in your specification are the volume of sludge that needs to be removed, the solids content of the in situ sludge and dewatered sludge, specific details about the materials and equipment that will be used for the project, how the dewatered sludge and filtrate will be managed. Of course, we all know that some of this information can't be accurately determined unless comprehensive testing has been done. So if one company is to be hired to do everything, they should present their plan and methodology to do the information gathering as well as the desludging. But if the procurement is being broken up into two parts, two specifications will be needed, one for the information gathering stage and one for the sludge removal and dewatering. Whether there are one or two components to the project, as much supporting information that is available should also be provided. That can include things like previous surveys, dewatering trials, analytical results, and site drawings. Once an RFP is issued, vendors will have access to the specification and the supporting documents. But for some, that won't be enough, and they will want to contact you to ask questions and gather more information. But collecting that information takes time, so please make sure that sufficient time has been allocated for potential partners to visit the site and conduct the tests that are needed to make good project estimates. You should also be prepared to provide information such as site drawings and utilities like piping, aeration, and electricity. Aeration systems and other obstacles on land or in the lagoon also have a big impact on how desludging is approached. So be ready to talk about your plans for those infrastructure assets and how they can be worked around. Management of the filtrate and dewatered sludge are also big parts of a desludging project and need to be addressed in the proposal. Vendors should be able to provide options for these steps and either incorporate them into their proposal or recommend others for those aspects. Ideally, your desludging partner should be able to provide a turnkey solution for you. The list on this slide shows the essential services that you should expect from a qualified, experienced service provider. These include collaborative project development, sludge survey, dewaterability tests, process design, project scheduling, equipment setup and operation, project management, management of dewatered solids, troubleshooting. To confidently select a service provider, they should be able to demonstrate experience and proven success in each of the categories, develop specific plans for your project, and execute each deliverable safely and competently. You should also look for contractors that offer a process that is capable of meeting permitting requirements. For example, the Bishop Solids Management Solution has a mobile environmental compliance approval for Ontario for the use of geotubes and polymers. This means our customers don't have to obtain permits or alter the ECA of their plant to use our desludging services. Other attributes that will help your project go smoothly include a vendor that has a mobile system with a self-contained generator that can be brought to site and quickly set up. An automated polymer injection system is also a big advantage. A good one will take frequent readings, about every 15 seconds, and automatically adjust the polymer dosing based on the sludge flow rate and sludge concentration. This will ensure polymer dosing is precisely controlled to optimize dewatering, avoid residual polymer and effluent, and keep polymer costs in line with estimates. A good desludging contractor will be highly accountable for their performance and meeting the terms of your contract. Be sure that your contractor will provide regular reports on the volume of material they've processed, the average percent solids of the material processed, and the test results of filtrate water quality. This data can be presented at regular intervals or collected over the course of the project and provided upon completion. To finish up this part of the webinar, here's an example of a lagoon sludge cleanout that our team recently completed at the O'Leary Wastewater Treatment Facility in Prince Edward Island. A couple of years ago, the two-cell lagoon began experiencing serious blooms of blue-green algae and exceedances of TSS, BOD, and coliform bacteria in treated effluent. Hydrogen sulfide gas was also accumulating in a below-grade chamber and caused serious corrosion to ductile iron pipes, an electrical panel, and a UV system. The town began with a sludge survey that was done by the local WSP team. The results showed that despite the large area of the lagoons, they are relatively shallow and had accumulated a lot of sludge, which was impeding their ability to remove nutrients and settle solids. Bishop Water was selected to perform the sludge removal and dewatering of both cells with their solids management system. After completing our sludge calculations, we built a dewatering area that would accommodate 3 geotube units across the bottom and 2 more stacked on top. This helped reduce the footprint and the cost of the dewatering area. We completed the project in about 5 weeks and removed about 872 bone-dry tons of sludge. Since then, there have been no issues with algae, gas emissions, or effluent quality. The on-site storage and consolidation that the geotubes provide also enables the town to spread the cost of disposal over several years. Aside from the budgetary benefits, the material will continue dewatering and experience freeze-thaw over the winter, which also helps expel more water. We estimate that the material could achieve 40% dry solids over time. To close the presentation, I'd also like to introduce a couple of our other simple low-energy solutions that can also be applied to lagoons to enhance nutrient removal. First is Bishop BioCord reactors. BioCord is like a condominium for bacteria that creates the ideal home on which bacteria can thrive. This attached growth process can be installed directly into a lagoon cell to improve cold weather nitrification and help the lagoon handle high strength or variable loading events. It's scalable, so we can install the right amount to handle current needs and easily add more if loading increases. BioCord is equipped with a unique aeration system that relies on compressors rather than blowers, which helps reduce energy costs. Overall, a BioCord system can offer capital and operating costs that are up to 50% lower than alternatives such as MBBR. I'd also like to introduce you to Clarifos, a coagulant technology that's made with rare earth elements, cerium and lanthanum. Clarifos performs significantly better than alum or ferric-based coagulants for phosphorus reduction because it forms a denser, more stable precipitate that settles out about twice as fast. That enables treatment plants to achieve ultra-low phosphorus levels without the need for costly tertiary filtration systems. Clarifos also works at a much lower dose than alternatives, which means far less sludge is produced, up to 50% less. And of the sludge that is produced, it dewaters up to 40% better than alum or ferric sludge, leaving a lower volume to manage. Clarifos is dosed with the same equipment as other coagulants, so it's very easy to switch. Just replace the current coagulant with Clarifos. One of the only issues we've experienced is that in a couple of cases, the dose has been so low, we've had to install a smaller pump. There are over 50 sites that have switched to rare earth coagulant technology to achieve lower phosphorus limits, reduce sludge production, or avoid large capital expansion costs. One of the most recent is Kingsville, Ontario, which is evaluating Clarifos as a replacement for ferric chloride to cope with increasing phosphorus loading from the many greenhouses in the area. The objective is to meet regulatory limits and avoid the need to expand capacity or add a tertiary filtration system. Clarifos is also being evaluated by the Ohio EPA for its potential to become an important part of the state's water quality toolbox and improve phosphorus removal at wastewater treatment plants. This is part of an initiative to reduce nutrient loading to Lake Erie and lessen the intensity of toxic algal blooms. All three of the solutions we've talked about today, the solids management solution, BioCord, and Clarifos, can be individually or simultaneously applied to a lagoon system to improve performance. This diagram shows one example of how that might be done. Geotube containers can be installed as part of an ongoing sludge management strategy, and they can also be used to accept septage, eliminating the need to put that high-strength waste directly into the lagoon. BioCord, as we've just learned, is installed directly into a lagoon cell and can be easily expanded if greater nutrient removal is required at a later point. Clarifos can be dosed as the sludge is being pumped into the geotube, or it can also be added to effluent in a polishing lagoon to precipitate phosphorus. Regardless of what type of project we work on and which of our systems are deployed to the site, delivering excellent customer service is our top priority. That starts right from the beginning with thoughtful and informative assessments, followed by careful consultation to develop the scope and deliverables for each project. Many of the components of our system are manufactured in Canada, and our team continually evaluates and improves operational processes so that we can maximize performance and value. We do everything that we can to ensure that projects are delivered on time, on budget, and with the highest standards for safety, performance, and responsiveness. We have a knowledgeable and highly experienced team that is ready to assist with all aspects of planning and delivery of lagoon cleanout or upgrade projects anywhere in Canada. You're welcome to contact anyone from Bishop Water at any time. In addition to Kevin and myself, we also have Keith Galloway and Mark Rancourt, two of our experts in chemical conditioning and geotube dewatering. For those outside of Ontario, feel free to contact our regional representatives. In Atlantic Canada, we have Paul Saunier of Scotiatech, and those in Western Canada can speak with Don Burgess of DWG Process Supply.
Thank you very much. I really appreciate you spending the time with us today. Thanks to Tyler And the people who put this together, I hope you found it informative, and it was most appreciated that you've listened to us and the questions. And if there's any follow-up, any one of us would be very happy to chat to you about the specifics of your project and or your lagoon. So thank you very much.